Real numbers, algebraic essentials. We're going to start by just classifying real numbers. We have the natural numbers, which are 1, 2, 3, and so on. And then when we go ahead and add in the number 0, we have the whole numbers. To get the integers, what we do is we take a look at the positive and negative natural numbers and 0, -2, -1, 0, 1, 2, and so on. And then we have the set of rational numbers, and that's basically your fractions. Numbers of the form of m over n, where m and n are integers and the denominator n is never 0. And the very last of the classification is the irrational numbers. And these are the numbers that do not have a terminating or repeating decimal, numbers like pi, square root of 2, and so on. And so with the real numbers, they're kind of embedded. In other words, all the rational numbers will include the integers, all the integers will include the whole numbers, and all the whole numbers will include the natural numbers. Now the next thing we're going to do is take a look at order of operations, because whenever you do a calculation, you do follow a specific order. And so people remember the acronym, please excuse my dear Aunt Sally. And that stands for do parentheses first, and then turn to the exponents, and then moving from left to right, look at multiplying or dividing, and finally, again, moving from left to right, look at adding and subtracting. So if I was to do this calculation, I would look inside the parentheses first, and I would do the calculation. And even inside the parentheses, I do have to pause, because what I see is 1 plus 3 squared. So I have a choice. Do I add or do I apply the exponent of a 2, looking at my order of operations?
Would you do the exponent?
Exponent first. So I have 1 plus 3 squared, which is 1 plus 9. And then I'm going to go ahead and look at my parentheses, and 5 minus 1 is
4.
4, so I'll take care of that. But if you have a real eye for detail, you'll notice that the parentheses are not quite completed. I still have a set of parentheses to evaluate. What am I driving at? What's my next step going to look like?
Would you add 1 plus 9?
Which gives me what?
10.
10. So I have 6 times 10 plus 3 times 4 divided by 2. And now I'm left with just the choice of multiplying and dividing or adding and subtracting. I know which would come first.
Multiply and divide.
And we move from left to right. 6 times 10 is?
That is 60.
60.
Right.
And then I'm going to move from left to right, so I'd go ahead and do 3 times 4, which is?
Which is 12.
And 12 divided by 2 is?
Is 6.
And finally, the last thing I do is add, and I end up with?
You end up with 66.
Beautiful. Next thing we're going to look at is properties of real numbers. When we look at properties of real numbers, we'll do an example from both addition and multiplication. Commutativity just means you can interchange the order when you add. 2 plus 3 is going to give you the same result as 3 plus 2. And 2 times 3 is going to give you the same result as 3 times 2. For associativity, this gives you the right to work inside the parentheses first, and you can choose where you want the parentheses to go. I'll show you what I mean. If I go ahead and take a look at 2 plus 3 plus 4 and place parentheses around the 3 plus 4, since I'm adding all the way through, I could also go ahead and look at 2 plus 3, perform that addition first, and then add the 4. And similarly for multiplication, I can take a look at 2 times 3 times 4 in parentheses and say that would be equal to what? It would be equal to 2 times
2 times 3.
In parentheses times?
Right, times 4.
Times 4. Distributivity just means I'm going to distribute. I'm going to move. I'm going to move a multiplier through an addition set of symbols. So if I had 2 times 3 plus 4, if I distribute the 2, that means I can take 2 times the 3 and then add to it 2 times the 4. And people draw kind of these arrows to show the distributivity that's involved. As far as my identity element is concerned, well, for my identity element, I'm looking at the element itself that gets me back to that number. So 2 plus some number is going to be 2, and that number would be what?
I'm not sure.
Yeah, 2 plus what is 2?
2 plus 0 is 2.
0 is the identity element. Beautiful. Same with multiplication. I would multiply by a number to get me back to that element. 2 times what would be 2?
2 times 1.
Very good. So there 1 would be the identity element. 0 the identity element for addition, and 1 the identity element for multiplication. Inverse means you take an element you say, yeah, like a real number, and you would add the inverse to get back to the identity element. Well, for addition, the identity element is 0. What number would I add to 2 to get me back there?
Would it be
-2.
-2?
Good. And for multiplication, I'd have to think about multiplying 2 by some number to get me back to my identity element of 1, and that number I'd multiply by is
1/2.
1/2. So the additive inverse of 2 is -2, and the multiplicative inverse of 2 is 1/2. For simplifying expressions, we are going to use our distributive property, and we're going to combine like terms. Variables with the same exponents on each term can be combined. So if I take a look at this simplification, the first thing I would do is distribute the -5 to both the y and the 4z. And all you're doing is saying to yourself, -5 times y is
-5y.
Yeah, it's almost silly to say, isn't it? And -5 times 4z is
Is -20z.
very good. And then minus 10x.
Right.
And when I use the phrase combine like terms, I'm saying I can combine the terms where the variables and the exponents are the same. And when you go ahead and look at this, you're saying you must be referring to the terms with what? With
With an X.
With an x. So actually what you're doing is you're saying that you can go ahead and take 2x. When you subtract 10x, you're almost looking at the distributive property in reverse. You're looking at 2 minus 10, and the x being on the outside.
Oh.
So I'm driving at what? I'm driving at the fact that my next step is to take 2x minus 10x. This will give me,
-8x.
very good, minus 5y minus 20z. There's my simplification. One last point, solving. If I solve, what I want to do is find the value of x. So I want to isolate it. So x is trapped in parentheses, so the first thing I'll do is use the distributive property to remove the parentheses. What happens when I multiply a 10 through the parentheses? I get what?
You'll get 10x plus 20 equals 30.
Beautiful. Now because I'm solving, I'm going backwards from the order of operations. Order of operations, I would multiply and then add. When you're solving, reverse it. You would look at the addition and subtraction before the multiplication and division. So to isolate x, I'm going to subtract a 20 from both sides of the equation. And if I do that, I'd have 10x plus 20, and then I would subtract a 20 from both sides of the equation. And what would that give me? That would give me 10x is equal to?
Is equal to 10.
Very good. And my last step is to take the 10 that's in front of the x and move it to the other side, is what we kind of say colloquially. But what you're going to do is divide both sides of the equation by what? By
10.
By 10. We find that x is equal to?
1.
1. Beautiful job. Thank you.